Hello everyone, welcome to the discussion on digital signal processing, lecture 2, myself Sivanantham. In our earlier lecture we have discussed about basics of signals and system. Now we will look into the classification of discrete time signals. We all know that what is a discrete time signal. The amplitude of the signal is specified only for some discrete instance of time. That means for the remaining time instance, the amplitude is not defined. Such signals are called discrete time signals. By nature, most of the signals are analog in nature. By means of sampling process, we are getting discrete time signal. By obeying Nyquist theorem or sampling theorem, we can recover the analog signal back from the discrete time signal. So, into the classification of signals, the discrete time signal as well as continuous time signals are classified as periodic signal and aperiodic signal. That means actually they are periodic sequences and aperiodic sequences for discrete time version. Similarly, even sequence and odd sequence. On the other hand, for analog signal, we should call that as even signal and odd signal. Next one, deterministic sequence and random sequence. Here the behavior of the signal, of the sequence, cannot be determined earlier itself. Such signals are called, or such sequences are called, random in nature. Next we will discuss about energy signal and power signal. Now, with respect to periodic signal or periodic sequences, if the signal is repeating for every n samples, in analog category we have mentioned the term as capital T here. That means for every t seconds it is repeating. Similarly, here in the case of discrete time version, we have a capital N here, which means for every n sample, the signal is repeating itself. If the characteristic of the sequence is repeating itself after certain interval of time, that means certain number of sequences, after every 5 sequence or after every 10 sequence, if the sequence is repeating, then such a signal is called periodic signal. If there is no such repeatability, such signals are called aperiodic sequences. Next we will discuss about even signal or odd signal. A signal that is symmetric with respect to origin is termed as even sequence or even signal. Signal represents analog domain and sequence represents discrete domain. X of small n equal to x of minus n. Similarly, the condition to be satisfied for analog for odd sequences, x of n equal to minus x of minus n. Similarly, for the random sequence, if this is somewhat similar to the analog category, except this notation, x of n equal to 5 sin 100 by n. That means if the behavior of the signal can be determined by means of some equation, then it is deterministic signal, else it is random sequence. Random motion of electrons or noise signals. Such random signals can be analyzed by means of statistical parameters. We will discuss about the classification of system in detail in the next lecture. Thank you.